Hello, welcome. My name is Kior Vora and I'm the Regional Manager for Gefran, and along with my colleague Jeff Koff, we would like to thank you for joining today. We will be presenting a technology overview of the Sensormate tie bar measurement system. The Sensormate system is based on pressed-on strain gauge technology. I will go into a little bit of theory behind this technology. What is a strain/force sensor? The strain/force sensor is based on strain gauges whose resistance varies with applied force. It converts force, pressure, tension, weight, etc. into a change in electrical resistance which can then be measured. When external forces are applied to a stationary object, stress and strain are the result, which can then be converted into an electrical signal. A sensor is composed by an elastic element, steel or aluminum depending on the type of sensor, Wheatstone bridge made by a strain gauge bonded or pressed on the support or elastic element. Strain. Engineering strain is defined as the amount of deformation an object experiences compared to its original shape and size. Strain is calculated by dividing the total deformation of the original length by the original length. For this presentation, the objects that experience strain are the tie bars in injection molding and die casting machines. Wheatstone bridge. A change in strain of an object is measured by a Wheatstone bridge. When a stress is applied on the strain gauge, the four resistances of the bridge increase or decrease their value. This generates an electrical output which is proportional to the load. The sensors in this system enable exact measurements of bending compensated tie bar strains. These strain measurements are then converted to a force value within the software, enabling readings in microstrain, kilonewtons, or tonnage. The diagram above shows a formula used to convert the strain measurements into a force value. It's the cross-section of the tie bar multiplied by a constant, Young's modulus, which is then multiplied by the measured strain value of the sensors. I will now review some basics of the Sensormate technology. On the left is a picture of a standard bonded strain gauge sensor, and on the right is a pressed-on strain gauge technology used in the sensors for the Gefran system. This slide shows the procedure required for a general bonded strain gauge. Number 1, select the strain gauge. Number 2, remove dust and paint. Number 3, decide the bonding position. Number 4, remove the grease and clean. Number 5, apply adhesive. Number 6, bond strain gauge to measuring site. 7, press the strain gauge. Number 8, complete the bonding work. As you can see, there are many steps required in order to complete the bonding work for a general bonded strain gauge. The Sensormate system uses a pressed-on strain gauge technology. The strain gauge is located under the foil with magnets on each side of the strain gauge. The magnets enable the sensors to bond tightly onto the tie bar. This strong bond in turn enables surface friction. This friction causes the surface strains to be transmitted directly onto the strain gauge, which creates the same effect as a bonded strain gauge would. The main advantage of the press-on technology is that it enables a reliable, high-precision measurement within a much faster mounting time than a traditional bonded strain gauge. In addition to the quick and easy installation, other advantages are multiple use of the same strain gauge, no soldering or surface cleaning, no special strain gauge know-how needed. This slide describes the components of the QE1008-W wireless system. Number 1 is a USB stick that includes the instructions, software, and brochures. Number 2 are these actual wireless sensors, which include rechargeable batteries. Number 3 is the power supply with 2 connection cables for the charge bars. Number 4 is a replacement sensor, which is optional to purchase. Number 5 is the wireless Bluetooth receiver. Number 6, the repair kit. Number 7 are the 2 charge bars. And number 8, there's an operation manual under the foam insert. These are some frequently asked questions regarding the wireless system. How many sensors do I get with my kit? It comes standard with 8 sensors with the option to purchase 1 or 2 spares. How do I charge the sensors? Using the 2 charge bars and power supply included. I see flashing lights on the sensors themselves. What does that mean? The 2 LED lights on the sensors will indicate proper connection, battery status, and any connectivity issues. Refer to section 8 in the operating manual for more details. Does training come with the price of the unit? Yes. Your local RSM will come on site to assist in training. What is a calibration standard that I can reference? Recommended every 12 months, and it can be sent to the factory to perform this calibration. When mounting the sensors onto the tie bar, you will need to check the following. First, the sensors must also always be placed in pairs onto each individual tie bar. The picture on the left shows the sensors 1.1, 1.2, 2.1, 2.2, etc. These must be placed in pairs onto each tie bar. Also, the tie bar surface where the sensor will be mounted must be wiped off to remove any oil, paint, or any surface contamination. You will also need to check to make sure the batteries are fully charged. The recommendation is to charge all the sensors the night before. Also check the foil on the bottom of the sensor to make sure there is no damage. Lastly, the picture in the center shows two sensors mounted 180 degrees from each other. The sensors must be mounted at least 1 tie bar diameter away from the clamping plate. This enables a correct and accurate measurement. The sensors are now ready for the machine to open and close and take readings. This slide is an example of the readings that will be displayed in the SPEC'S software. On the top left-hand side is the total force value, and scrolling down you will see inputs for tie bar diameter in millimeters, Young's modulus, K-factor, and tolerance. Only the tie bar diameter value needs to be entered onto this screen. The other values are set at the factory and do not need to be changed. On the right-hand side, you will see values for each pair of sensors on the 4 tie bars, with total force value in the center. The values can be viewed in microstrain, kilonewtons, US tons, and also as the option for metric tons. On the top right, there is the ability to input the machine number, serial number, and any comments. All of this can be saved as a screenshot, Excel CSV file, or even printed out. Now Jeff will take you through the rest of this presentation.
Thank you, Kior. Welcome, everyone. I would like to take a closer look at the typical applications where Gefran's Sensormate system can be a useful tool in measuring strain or force. Here is an injection molding machine application where you can use strain and force sensors for test and calibration for specifically injection force in the machine itself and for clamping force and mold protection. Again, in this injection molding machine application, where specifically do we take a look at the clamping force and mold protection? So as you can see from the picture, specifically it is in the tie bar area itself, the toggle area of the machine, and the platen, the force of the tie bars putting force on the platen itself. Other areas on the injection molding machine application include the injection unit itself and behind the screw area of the machine. Test and calibration for the injection molding machine. Again, you can take a look at the platen, the toggle, the tie bar, and the nozzle. We have products that address all of those areas that you can certainly take a look at from Gefran. This is certainly a busy slide, but it's a good slide that gives you an idea of the number of applications that our Gefran Sensormate calibration system addresses. Core application for our tie bar system, tie bar calibration system, is plastic injection molding machines, robotic arm applications, hydraulic stamping presses, strain stethoscopes, do-it-yourself load cells, and die casting machines. You can see that the amplifier in the picture gives you an idea of what the amplifier itself looks like. And then we also show you the monitors that are available in the given systems below, from a one-channel display digital monitor to a four-channel type of displays, one of them being a USB interface that you can take back to a PC, which gives you versatility to analyze and store your data into a PC if that's more convenient. And then we also have the typical standalone four-channel digital monitor and display that is a less expensive solution. So the actual systems themselves are in the chart below. We start off, as I term them, good, better, and best. Good system being a GE 1029 series. The 1029 series utilizes straps themselves. When you buy the system, you get to choose a specific strap size for a given diameter tie bar. So if you have a number of injection molding machines that have different diameters of tie bar, you'll have to upgrade the straps for each application and the tie bar diameter that you want to address. So the GE 1029 would be entry level. The next level up would be the QE 1008, and that system essentially has the earth magnets for attachment to the tie bars themselves, so it makes things a lot more versatile and easier in terms of attachment to the tie bar. At that point, we do offer a USB version, as you can see down towards the bottom. So QE 1008 DU-4 USB gives you a four-channel solution, being able to interface back to a PC and again store your data, giving you a little more versatility. The final system is the QE 1008-W. So the -W set is the wireless set. That's essentially our fleet premier unit. A number of engineers love that system because its ease of operation being a wireless solution. You no longer have to take the doors off of the injection molding machine itself to make sure that you route wires back to the digital display itself or PC. So in this case, the sensors being wireless transmit back to a receiver, which is plugged into a laptop. And it makes it very convenient, not only convenient, but it reduces your machine downtime, and you're back up and running and probably can do a calibration in no more than 20 minutes. Again, from the previous slide where we saw all the same applications to the right, we can address certain compression or tension type force measurements. And we have a number of products that can address that through either bonded strain gauge type scenarios or technologies, and also press strain gauge technologies as well. So the SB series is very popular. It's a shear beam type of unit. It's very low profile, and it measures both compression and tension. We also have certain types of sensors that are round for specific areas on some of the applications we discussed that you want to measure compression or tension for as well. And then the flat and round series for more of the tie bar measurement type applications. They use a pressed strain gauge type of technology. The actual strain gauge that we use is very accurate and does a good job in terms of feeding back that measurement back to our system. We also have the nozzle pressure that we can do based on certain diameters. So consult with your regional sales manager in terms of the diameter that you want to measure nozzle pressure for, and we can tell you whether it's something we can do for you or not. And then certainly the final application there for the strain stethoscope, we have specific areas and applications that we addressed where we are competitively priced and can certainly help you out in terms of your application needs. Gefran Sensormate has a number of YouTube videos for everyone to view at their leisure. The Gefran Sensormate app YouTube video should be of particular interest to those of you that have further interest in our new QE Booster product. This product's recently come out and is getting rave reviews from a lot of users. This is the latest Bluetooth receiver that we have come out to market with that enables our wireless system to utilize your smartphone. This receiver supports Windows-based systems as well as Android and Apple products. The pinch to zoom feature for the graphical interface, especially on a smartphone, is very interesting and should provide even more granularity to your data. So I certainly invite everyone to take a look at this new technology advantage. Is something I think you'll be quite impressed with. I'm going to review the Gefran Sensormate tie bar calibration system and the advantages to using this system. There's no doubt that using this tie bar calibration system on a regular basis fulfills any requirements that a company has for regular documentation of the calibrations that you do on a quarterly or annual basis. There's no doubt a good practice for everyone to get in the habit of doing is to do these calibrations regularly. Different markets that a company addresses, like the medical market, have strict requirements for documenting tie bar calibrations. This system simplifies that task and minimizes the machine downtime for doing so. Our 8-sensor system can detect premature tie bar fracturing and can certainly help in preventive maintenance scenarios. After all, you don't want a large tie bar to snap and create even more damage to the equipment and create an even longer downtime for the machine itself. For older machines on your floor, this is considered to be a required maintenance step in your annual routine. No longer is there any need to outsource your tie bar calibrations. Gefran has simplified the task for you, and our wireless solution is the way to go. Buying our system will pay for itself in less than a year's time, and there's no doubt that a wireless system means less machine downtime in order to do this task. When I go out into the field and talk to certain maintenance engineers and I ask them how they do their calibration for their injection molding machines, They sometimes come back and tell me because of the market they address, they really have no real need to do a calibration. What they look for is excess flashing on the mold itself and eyeball the calibration based on that flashing. This slide really shows you the effect of uneven load distribution, showing how Tybar 2 only carries 10% of the load. The bottom line is that the parts themselves may not be showing flashing, but you will get parts in a corner, any given corner of that mold could be slightly heavier in terms of material because of the higher cavity volume. This picture is showing you the potential rupture locations that is caused by superposition of tension and bending on the tie bars themselves. The red dot on the tie bars themselves show where the maximum strain is in the tie bar. Over time, constant force on these tie bars could cause premature failure of the tie bars themselves. Here is how our calibration system can help you avoid possible tie bar rupture. As you can see from the picture of the tie bar, the force or strain flows through the tie bar in one direction, outward from the platen. By placing a pair of sensors parallel to one another, each sensor detects strain relative to the tie bar itself in microstrain and displays that reading on each channel of our software onto your PC or smartphone. You can see the larger microstrain number on the top sensor and the lower microstrain number on the bottom sensor. If you have this type of large difference between readings, it means that it's very likely you have a cracked tie bar and should think about replacing it before it actually breaks. Let's review the die casting machine area for load cells. Here's a picture of a typical die casting machine, and as you can see from the diagram here, we can certainly measure the injection force, and also the clamping force and mold protection are a big issue when it comes to the die casting machines themselves. So those two areas we can do using our load cell technology. The next slide, we're going to review the stamping press applications. The stamping press application is pretty straightforward, as you can see from the picture here on a typical machine. Strain and force measurement are done based on this clamping mechanism for clamping force. So again, an application for a load cell, compression load cell for this application. Okay, we saved the best for last. This is Gefran's new technology that they've come out with. This is the new QE booster receiver. It is the latest in Bluetooth technology that supports Windows 10, Android, and iOS products. This includes using your smartphone to now capture your data for calibration of your injection molding machine. As you can see from the picture, it's very small and it's very compact. Here are the QE booster technical specifications for both the USB receiver, which is the QE booster, and also the USB receiver. So you have a choice when you buy the system of whether you want the USB receiver that connects to your PC or whether you want the QE booster Bluetooth receiver in its place. There is no price difference whether you want one or the other. The power, you can see the power supply differences between the two. One is USB technology, it takes power from the PC, and the QE booster uses a standalone integrated lithium battery that lasts typically up to 12 hours of use. Okay, so finally let's get into the QE 1008-W, the wireless value proposition that we see. A lot of customers definitely benefit from the technology that we have. We utilize earth magnets on the actual body of the sensor and a strain gauge foil technology on the bottom onto the material that's to be measured. It's got a very high accuracy of less than 0.5% absolute, so it's similar to a bonded strain gauge advantage, but in this case it's press-on technology. You can use this for tie bar diameters from 45 millimeters up through 1,000 millimeters, which gives you a lot of versatility if you're doing calibrations and have more than, let's say, 15 to 20 machines. 20 machines is about the break-even point based on the price that you will definitely get your return on investment well within a year. This is a bended compensated measurement, which is a big plus. So you're actually getting the actual data itself, and it is reliable and accurate also on flat surfaces. The supplied display software gives you the option to save it in a CSV file format in a PC. So some people were saving their data with paper and pen, no longer have to do that. Now you have an electronic solution that can be filed on a PC that you can refer to at a later point. Also, it is a technology where the data, you can display it in terms of force measurement in kilonewtons, tons, US tons, or microstrain. Used to calculate that on your own based on some of the data, but our software gives you that data with that calculation already in front of you. There's no cables, big plus. Again, no need to take the doors off the machine itself. That could have taken you up to over an hour in terms of the calibration. With this wireless technology, it will give you the advantage to cut that calibration time in more than half. You could probably do it within a 20-minute window, and it will give you all the data that you need. It's a very compact design. We give you the case along with it. It's very portable. The software itself, there's no license required, so you can have the software on multiple laptops out on the floor. So these are all advantages that we see for the Gefran Sensormate tie bar calibration system, and I invite you to try it today and take advantage of this technology and put into good practice and preventative maintenance what you have here in front of you, and put it to good use. Okay, with that, I'm going to go on to the next slide, which I believe will tell you that that's the end of the session. So if there are any questions, comments, certainly we're going to have a question and answer period at the end of this webinar. So certainly stick around, ask your questions. I'm sure somebody will be there to answer your questions. All right, with that, I thank you, and hope to see you soon. If you'd like a demo, contact your Gefran regional sales manager. They'll be happy to come out and demonstrate it for you before you buy. Okay? Take care now.